Hi, everyone. This video, we're going to take a look at section 8.1, systems of linear equations in two variables. Let's take a look at what this means, systems of linear equations. So a solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. And so basically you're taking two lines, two linear equations. If we were trying to represent this using a graph, and seeing where these two lines intersect. So you're finding the x, y coordinates where these two lines intersect. So here in this case, where we're focusing is trying to find this intersection point. Sometimes though, you'll have lines where they don't intersect at all. And that's the case of parallel lines. We have looked at parallel lines before. And so this has no solution for parallel lines. Let me write one solution here. And the third case is when you have a line. And the second line is actually a line that overlaps the first line. So in this case, they're intersecting everywhere, right? So infinitely many points. They intersect or they meet at all the points because they are essentially the same line. So this is the same line. And so the intersection point is all real numbers. There are a couple ways to solve for the solution if in the case where there is an intersection point. That's the first way we're going to take a look at is the addition method. Sometimes it is known as the elimination method, but they're both the same thing. So if we look at this first example, using the addition method or the elimination method, 5x plus 6y equals -19. And then the second line minus y equals 8. So these are two lines again, and we're trying to find where do these lines intersect, at which x value and which y value. You have a choice here of trying to eliminate either the x or the y variable. And the reason we do that is so we can get it down to a single variable and solve for that variable first, and then use that variable to solve for the other variable. So in this case, we're going to try to eliminate y. If you look at the y's, you have a positive 6y and a negative 1y. The way we can eliminate the y's is if this second y is a -6, right? Because a positive 6 and a -6 would cancel each other out. So in order to do that, we're going to multiply the bottom equation by 6. So let's multiply the 6 by 4x, 24x. Let's multiply the 6 by -6y and 6 by 8. Remember to multiply each term in the equation by 6. And we get positive 48. The top equation, we're just going to copy it down again. We are not doing anything with it. 5x plus 6y equals -19. And now we're going to combine the two equations together. So if you have 5x, you add 24x, you get 29x. 6y, -6y, we'll cancel them out, right? We've eliminated the y. That's what we wanted to happen. And we add -19 and 48 together, we get 29. So now with x, we can solve for x by dividing both sides by 29. We get x is equal to 29 divided by 29, which is 1. Now, after we get this 1, we want to solve for y. We can solve for y by plugging it into either the top or the bottom equation. Which one? It really doesn't matter. You can choose that you just want to plug it into. Okay, so let's take one. Let's just substitute into the top equation. The top equation is 5x plus 6y equals -19. So we're going to plug in x in for, or 1 in for x. So we have 5 times 1 plus 6y is equal to -19. 5 times 1 is 5. add 6y equals negative 19. We can now subtract both sides by 5 to get 6y is equal to negative 19, and negative 5 added together makes negative 24. And we're going to divide both sides by 6. Y is equal to negative 4. Okay, so the solution value, or the solution point, the intersection point is 1, negative 4. If we were to see this on a graph, this would be the intersection point. Okay, let's take the same two systems, and in this case, let's eliminate x. So it's the same two equations that we looked at previously, and this time we're just, the only difference is we're eliminating the x. So if you look at 5x and 4x, right, the way they're written now, right, they can't be eliminated because they have to be opposite values. And so if you have 5x, right, we would want the bottom one to be negative 5x. But right now they're not. So a way to kind of change that is think about a number that they can both be, but be opposites, one positive, one negative. We can do that by multiplying the 5x by negative 4 and then multiply the 4x by positive 5, because then we would get negative 20x, and the top and the bottom would give us a positive 20x. But now we have to multiply with each term. So we have negative 4 times 5x, which is negative 20x. Negative 4 times 6y is negative 24y. And then let's see, we have negative 4 times negative 19. It's going to give us negative 76, I believe. And then repeat the bottom. 5 times 4 is positive 20x. 5 times negative y is negative 5y. 5 times 8 is 40. Oh, I made an error there. That should be a positive 76. I'm glad I caught myself, because a negative times a negative should be positive 76. And now we're adding both of these together. If we add negative 20x plus 20x, right, they're going to cancel, right? This time we're eliminating the x. Negative 24y plus negative 5y is negative 29y. 76 plus 40 is 116. Now let's continue, divide both sides by negative 29. We have y is equal to 116 divided by negative 29, which is negative 4. Shouldn't be a surprise because we had gotten negative 4 doing the eliminating the y. And now we can go back and now substitute y back in either one. This time I'll just substitute back into the second equation. 4x minus y is negative 4 is equal to 8. We have 4x plus 4 is equal to 8. Let's take away the 4 on both sides of the equation. 4x is equal to 8 minus 4, which is 4. And then we divide both sides by 4 and get x is equal to 1, which is 1 comma negative 4, which is the same exact solution that we had gotten doing the other way, eliminating the y. Okay, so it really doesn't matter whether you eliminated the x or the y. In this case, it was easier to eliminate the y because this bottom one, we only had to multiply the bottom to get rid of the y's, but eliminating the x is fine. Some of you may wonder, can you multiply the top equation by positive 4 and the bottom equation by negative 5? Yes, you can also do it that way as well, and you'll end up with the same solution. Let's try another one using the addition method. We have 2x minus 3y equals 11. 5x plus 2y equals negative 1. Again, decide on which one you want to eliminate, either the x or the y. Really doesn't matter. I'm going to eliminate the y's because one's already negative and the other one's positive. So it looks like we need to make them opposites. I think what we can do is multiply the top equation by 2 to give us a negative 6y, and the bottom equation by 3 to get a positive 6y. So let's multiply the whole top equation first with 2. So we have 2 times 2x, which is 4x. 2 times negative 3y is negative 6y. 2 times 11 is 22. All right, so the top equation is all multiplied out. And now we can multiply the bottom equation. 3 times 5x is 15x. 3 times 2y is positive 6y. 3 times negative 1 is negative 3. Let's add the two equations together. The like terms first. 4x 15x is 19x. Of course, the negative 6y and positive 6y are eliminated. That's what we wanted. And now you can see why we're calling it the elimination method sometimes. And again, we call it the addition method because we are adding the two equations together. 22 minus 3 is 19. Okay, so now we divide both sides by 19 and get x is equal to 1. Okay, don't stop here because we have to also solve for y. Again, it doesn't matter which one. I'll just do the top. Let's write it down. 2x minus 3y is equal to 11. We're going to substitute 1 in for x. So we have 2 times 1 minus 3y is equal to 11. 2 times 1 is 2 minus 3y is equal to 11. Subtract 2 on both sides to get negative 3y is equal to 11 minus 2, which is 9. Divide both sides by 3. And y is equal to negative 3. You can always check your solution by substituting it into both the top and the bottom equations as well. Okay, let's try another addition method problem. This time we have 6x equals y minus 6, 6x minus y, or 6x equals y minus 6, and 6x minus y equals 4. If you notice, it's not lined up with the other one. So you have the x here. Now you have the equals on this one, but you have minus, and the equals are not lined up. So we have to make sure that everything's lined up. So let's take the top equation here. And we have 6x equals y minus 6, and subtract the y over and get 6x minus y is equal to negative 6. So we've rewritten the top equation so that it does match the formatting of the bottom equation. And we have 6x minus y equals negative 6. The bottom's the second equation. Let's just copy 6x minus y is equal to 4. And now we can either eliminate the y or the x. Again, it doesn't matter which one you choose. Let's eliminate the y's again by multiplying the top equation by negative 1. Why negative 1? Because that will give us a positive y, which will cancel out with the negative y. So we have negative 6x plus y is equal to positive 6 actually. In the bottom equation, nothing happened there. 6x minus y is equal to 4. Okay, now that we have these two equations, we're going to add like terms, negative 6x and 6x. It looks like they cancel out. That cancels out. So we got 0 equals 10. Okay, when is 0 equal to 10? This is never true, right? This is a false statement. All right, it's never true. So it's false statement. What that means is these two lines never intersect. So there's no solution. Because if they were graphed, these two lines would be parallel lines. And so because these two lines, if we were to graph them, they would never intersect because they're actually parallel lines. So this is no solution.